right, so when we're talking about the fundamental theorem of calculus, or the second fundamental theorem of calculus, let's first just review, what is the fundamental theorem of calculus? Give me any kind of words or phrases you remember from it.
Big F of A.
The big F of A minus F of B. What were we doing? We were integrating, and then we were plugging in numbers and subtracting them. And geometrically, what did that represent on?
Area under the curve.
It represented the area under the curve. That's the fundamental theorem of calculus. This right here is saying, well, what happens when you have an integral and you take the derivative? Well, the derivative and the integral do cancel out. But when you have items on the integral like this, you've got to do a little bit of extra work. And so when we see this, we can see that it's f of x. Now, I'm going to go ahead and write specifically more that cancels out. It's still just f of x, but let me show you what happened. So basically, the d in the integral, that canceled. All right, so we're left with just this f of t. And then we're plugging in x, and then really what they're doing is taking the derivative of x, which would be what? 1. Okay, and then we're minusing f of a. Now here, let's say that a is a number. So what would be the derivative of that number?
0.
0. So do you see how this still simplifies to just f of x? Okay. What does this look like when we multiply by the derivative of something? What rule does that make? Well, we did the rule, and then we said, oh yeah, now we got to take the derivative of something, the chain rule. It's kind of like chain rule. It is chain rule, but it looks different. So let's do some examples. Find the derivative of big F of x. This means find big F prime of x. Okay? So what this is, you're right. What we're going to do, and I'm going to go ahead and write it all out right here. We're going to take the derivative, big F prime, I took the derivative of the left, now I take the derivative of the right, of the integral. Now, the derivative and the integral are going to, in essence, cancel out, but I still have these things that I'm going to plug in, okay? But I'm going to also keep in mind that I'm doing derivatives, like a chain rule, at the same time. So let me show you what I mean by that. This t squared plus 1, that's going to stay. I'm not taking the derivative of this part, and I'm not integrating it. I'm doing both. That's why it's not changing. If you wanted to distribute that t, you could, but I'm not going to. You don't have to. Now remember when we did integrating before, we wrote a line. That meant, hey, we already did do the integral, okay? But now I'm going to show what I need to plug in. And notice that I'm missing a plus c. Why do you think I'm not writing plus c here?
It's going to be 0 anyway.
Why would it be 0?
Just take the derivative.
Because I'm taking the derivative. That's one reason you could look at it. When else did we not do plus c? It has to do with these.
Oh, yeah.
If I'm going to plug this in and subtract, what would happen to the c's? They would cancel out. Okay, so that's another reason. So there are actually 2 reasons. Okay, so what we're going to do is we're going to plug 2x in for t. So we got 2x here. And then we've got, I'm going to go ahead and square the 2x to make, this is kind of sketchy today. Here we go. 4x squared plus 1. And now I need to multiply by the derivative of what I'm plugging in, which was how much? I'm plugging in a 2x, so the derivative of that would be 2. Okay, and then I have a minus. Okay, now I'm going to plug in x. So I have x squared plus 1. And then if you want to write the times 1, you can, although you don't have to. You know that it's times 1, it doesn't do anything. All right, this is fine. You can definitely simplify. In my earlier classes, I focused on them simplifying, and I'm not going to do it here because I want to spend more time on other things. Okay? Does everybody feel like they could simplify this if they needed to? Yeah? Okay, hopefully the answer to that is yes. Distributing, combining like terms, all that. All right, so I want you to see what's different about 4. Whoops. Did not mean to do that. How is 4, in particular, these things different than 3?
It has trig.
It has a trig. And are they both function, like it's like almost kind of like there's a function as the endpoints. But here, that's a number. And that's going to cause something to happen. I'm going to see if you can figure it out. So I'm going to go ahead and write this out. I want to make sure that it's clear. And I don't just want to find the answer. I want to prove that my answer is what it is. And the nice thing about this theorem is you don't really have to do a lot of work. Like, you don't have to do the derivative. You don't have to do the integrating. Okay, the derivative and the integral do cancel, but you still have this idea of I've got to plug in my numbers or functions. Okay. So when I plug in x cubed, I've got cosine x cubed, but I need to turn around and I need to multiply it by the derivative of x cubed, 3x squared, okay, minus cosine of pi over 2 times the derivative of pi over 2, which is 0, because pi over 2 is a number. And so it's 0. So you could go ahead and, like if we were simplifying here, whatever, okay? But cosine of pi over 2 is 0, but you could have figured out, in fact, I am just going to go ahead and rewrite this as 3x squared, because this would be a great multiple choice question. And I think some of you are not getting that this can go in front. And I'm going to go ahead and write minus 0. Because that's how you might see it, even though we know if it's minus 0, you don't have to write minus 0. If this was just like this question, you could write it the first way, this way, also without the minus 0. But I want you to see that because of that pi over 2 was a number there, you really didn't have to do anything, right? Because we know that when we take derivative of that, we're going to get 0.
Is that always the case with this number?
Yeah, when you're doing this, when you're doing derivative of the integral with the endpoints, yes.
Okay.
Okay, so looking at number 5, I'm going to switch colors so it's kind of easier to see from problem to problem. All right, so here we have big F prime of x. That's going to equal the derivative of the integral. And again, notice that this is a number. So my second term, I already know is going to be 0. Okay, I already know that. So I'm kind of getting ahead of myself. First, I just need to write absolute, or not absolute value, square root of t with 5x squared and pi over 3. And when you plug in the square root of 5x squared, that could be simplified because of the square root of x squared. So before I even get to that, I'm going to do times the derivative of 5x squared, which would be how much? 10x. And now, this is where you could just write minus 0. You don't have to do square root of pi over 3 times 0. Because we're taking derivative of the endpoint, we're just writing that has to be 0. That means that whole term has to be 0. And then I'm not going to simplify this one either.
That would just turn into 5x, right?
It would turn into, if we simplified, the square root of 5 would have to stay inside. Because 5 itself is not a perfect square.
Oh, okay.
Like, if that had been 25, yes.
Okay.
And this is though where it's always better to not simplify because you can make mistakes like that. If you simplified this though, the answer would be 10x squared, square root of 5, although you may see it as 10 square root of 5, and then the x squared or something like that. Okay, so in looking at this one, when I get to plugging it in, okay, that's fine, and the derivatives of both of these are going to be 1. So you don't really have to do a whole lot. I want y'all to go ahead and do this one on your own. Don't forget, I would go ahead and write it in, like the whole times thing, just so that you get in the habit of doing it, even though when it is 1, and it happens to be 1 a lot of the time. if you're feeling any kind of confusion about what to do from this step, remember you're plugging in this term here, and it's a whole term, in for t. It's not being multiplied. So you should not have any t's at the end of the problem. They should all be replaced. It's always f of this minus f of that. Now, I didn't put in the times 1, even though I told y'all need to be doing it. But I want you to look at my answer and tell me, is my answer accurate? And I'm asking you this, so the answer is probably no.
Do you need to do you have to
Okay, so I want you to see, I plugged in x plus 5 in for t. So 3x plus 5 minus 7. Okay, this was the first term. I could have put times 1, although that would not change it, right? Okay, this is my minus that goes in between, and here's my second term. What's wrong with this statement? Where do I need parentheses? Around the 3x minus the 7. Why? Because that minus applies to everything. This is the kind of thing, you don't want to be the person that understands second fundamental theorem of calculus but doesn't distribute your negative. You don't want that to happen to you. That's a sad situation. I'm not saying it's sad like you're pathetic, I'm saying it's sad like it hurts me to think that students might miss points because of something they really do know how to do, but they're just forgot about it. So just remember that you're subtracting, something that's could be more than one term. That hadn't happened until this problem. All right, we're going to skip 7 and we're going to move on to this AP problem. Yeah. Yeah, that was the answer. We definitely could simplify. Okay, and I'll tell you on this one, if you do simplify, you get 15. The x's end up canceling out and you're just left with 15.
Which should answer the second.
Not off the top of my head. I can check it out. All right, let's move on to this because I definitely want to get through this problem and I want to spend a lot of time talking about it and maybe even the next one. So these problems right here, I want you to see what you're given and then what they're asking you about. They give you a graph of f. Okay, I'm going to circle that f, I'm going to underline it, whatever. Okay, this is f. It's not anything else, it's just f. Then they say the graph of the function f shown above, so they really want us to know this is the graph of f. Consists of a semicircle and 3 line segments. Then they talk about another function g, and they give us a formula, an equation. So how many functions do we have on the table right now?
2.
Really, you can answer this a lot of ways, but you should have said at least 2. We've got f up here, and then what function are we going to do? G. You got at least f and g. Now you could say, well, if we're integrating or if we're taking derivatives, those are new functions. You could definitely argue that. Okay, so remember, they gave us f, they give us a formula, and then look at which function they're asking us about. About g. So I want to make sure we understand really what this problem is doing. This is a very common problem. You will definitely have something like this on the AP test. They give you a graph of f, and they ask you about g. And the only thing you have to relate the two is this statement right here. Okay? So before I go through all the questions, I want to make sure we really understand how f and g are related to each other. Okay, up here, I'm going to go ahead and write that g is the integral of f. And what I did is I just kind of got rid of all the x's and t's and numbers and stuff like that. Just g is the integral of f. If I were to integrate f, okay, geometrically, what would that be about this graph?
Under the curve.
The area under the curve. So we're going to write that as well, area. All right, Now, later on they're going to talk about G attains a relative max, and we're going to need to know something about G prime. So let's take the derivative of both sides. So that would be G prime. What would be the derivative of the integral of f? Yeah, just f, right? And now this is the graph of f. So these are the y values of this graph. Now I'm doing a lot of prep work, but it's going to make the rest of the problem a lot easier, and every problem is going to work out this way. You're going to write basically the formula, you're going to take the derivative of both sides, and we're going to see this happen again. All right, now I'm even going to go ahead and do G double prime, because I see down here that G has a point of inflection. Points of inflection, that has to do with concavity, second derivative of G. What would G double prime equal? F prime, right? You just took the derivative of both sides. Now, if this is the graph of f, what is f prime? I mean, think about, okay, so let me ask you, what is f prime right here? Think back to what a derivative is. If you had to explain derivative to someone not calculus. Well, you guys are answering a question. You're going beyond what I'm asking. But I guess what I'm asking is, if you had to describe derivative to someone, you would use the word slope, right? So G double prime, which is the same as f prime, that has to do with the slope of this graph. So if I wanted to know something about G double prime, I would actually look at the slopes of this graph. Now this is a lot of prep work, it is, but these problems all work out the same way. Okay, you start with area, then y values, then slope as you take the derivative each time. Okay, this is going to be very valuable when you get into this problem. We're going to use all this information. Okay, so let's go ahead and do part A. All right, so part A first says find G of 0. All right, the only thing I know about G is this formula and how it relates to the graph. So if I know that G of x equals this, then I'm going to go ahead and plug in 0 in for x. So G, not G prime, not G double prime, has to do with area. You should be doing something with area to figure this out. And that should be clear when you see that integral sign as well. That's an area. So we want to find the area from x equals -3 all the way to x equals 0. And I want to find area of that shape. What is that shape? It's a trapezoid. Do you know how to find area of a trapezoid?
Yes.
You should. Yeah. Average the two bases. The bases are the parallel sides. So what are those? Be careful. 1 and 2. All right, and then we need to multiply by the height. Now the height on these trapezoids is generally actually the horizontal length. All right, because the bases have to be parallel to each other. The height here then is how much? 3. I'm going to redraw this trapezoid over here just to make sure that we've all got it. Okay, this is the same trapezoid as here, but I've rotated it a quarter turn. So you average the two bases, 1 plus 2 over 2 times 3. So this ends up being 3 over 2 times 3. That's 9/2, or you could definitely write it as 4.5. Now, I think probably most of you could have figured out that G is 0 and all this without me writing this. Okay? But then we get to the next part of A, which is G prime of 0. And remember that we're not looking, we can't just look at this graph and just get it automatically. We've got to think. G prime of 0, G prime is the same as f. So we're going to do f of 0, and also, I know that this is a y value because I'm given the graph of f, therefore I need to find f of 0, that's the y value, so what's my answer? 1. if you kind of approach to g prime of 0 without thinking through this over here, it's likely that you could make a mistake.
So in the AP test, if you just looked at that and knew it was 1, could you just write G prime of 0 equals 1?
I'm pretty sure on the AP test they would not require you to write f of 0, but I mean it's 1 point. You get it or you don't. Close gets you nothing. Because these are 9 points, so I'm pretty sure g of 0 was 1 point and g prime of 0 was 1 point. All right, let's do part B now. So part B, and I'm just going to have to scroll up and down. Part B says find all the values of x in this open interval where g attains a relative max. Okay, so we know that a max looks like that. Okay, before I get to how this relates to f, what do we know about g prime if g has a max? What's the deal with g prime?
Concave down.
Okay, so I'm hearing several things, so let's start this. Yes, this graph is concave down, but that has to do with g double prime, which I could get to, but that's a little bit more work than I want to do. G prime is changing from positive to negative. Okay? G prime has to change from positive to negative to ensure that G has a relative max. And they're going to ask us to justify our answer, so it's good to just go ahead and write down what you're thinking so that you'll make sure you know how to justify it. Well, what's the same as G prime? F. So, which are y values. So we want to know where are the y values changing from positive to negative. There's only one place where that's happening. At 3. This is the only place. So I want you to notice this, if you just do one piece at a time and follow like the cookie crumbs, you're going to get to it. It's not that hard. But you've got to go slow and you've got to really think through it. G has a max. When G prime changes positive to negative, G prime's the same as F, positive to negative. All right, so x equals 3. And we do need to write our justification. And we could say, there's definitely different ways you could do this, but I'm going to say G prime, which is the same as F, changes plus 2 negative. Just writing G prime, the problem with that is G prime isn't on this graph. Yeah, it's the same as F, but you gotta always relate it back to F. You should have something about F in the problem.
Should you say because G prime equals F, it changes positive to negative at x equals 3?
Sure.
Because I know it's implied, but they taught us that. So
Yeah, you're right. And this is something we're going to get better and better at, but yeah. Really, we should probably say G has a relative maximum at x equals 3 because blah, 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 at x equals 3. All right. So C says find the absolute minimum. Okay, absolute minimum. This is different than relative minimum. Could the relative min be the absolute min?
Yeah.
Sure. Where else could the absolute min come from?
Just the opposite.
Okay, I'm going to write this. We need to consider the relative min. And for those watching the video, this won't make sense, but I want y'all to look up at me. Let's say I had a function, and it starts here, really low, and it goes up high, and it has a lot of mins and maxes, and it stays high. Where was the absolute min? Where I started. Was that a relative min?
No.
No. So it could be an endpoint. Or really, I should say and endpoints. Okay, so let's think about where are the relative mins. Okay, well, we did a relative max just a second ago, so really we're just thinking negative to positive. So where is that happening? At -4, x equals -4. Okay, good. And the endpoints, that's pretty easy. x equals -5, and x equals 4. And when you're doing absolute extrema, you always have to plug it back into the original. Now here we're saying absolute min of t, so I'm going to do a t-chart, okay? X, and g of x. And this actually is going to be, this is acceptable for your justification. When we get to that, this t-chart is going to tell us everything we need to know. So I'm going to go ahead and list these in order. You wouldn't have to, although, you know, it kind of looks nicer to list these in order. And so what I need to do is I need to find g of -5. I need to find g of -4. I need to find g of 4. And the lowest one, that's my absolute min. Well, have we yet on this paper done g of some number? Look back to A. We did do g of 0. And g of 0 was the area under the curve. It was this trapezoid. So that's what we're going to have to do. Okay, that means we're going to have to be using this formula. And so g of -5, if we use the formula exactly as it's written, which is what you have to do, is that f of t? Yeah, dt. There's something about this that seems off. Yeah, we have our bounds switched. Okay, the number down here should be the smallest. So I'm going to switch them. And if I do that, I have to do something else. I have to put a negative in front. Exactly right. Okay. It doesn't mean that my final answer has to be negative. It means that I need to multiply the integral by a negative. Okay. So -5 to 3. I'm going to do this in a different color just to kind of highlight it. So -5 to 3 would be this area and this area, keeping in mind that area itself is not negative, but the integral of area under the curve is negative. You would subtract that, and the area above, we would add that. Look at those two shapes. They're the same, so what's the integral? So 0, right? So the negative ended up not mattering because it was -0. On the next one, though, it is going to matter. Okay, so let's do this one. Same thing. We plug in the -4 where the x was, which was at top. Again, these bounds are switched. So what you have to do is consider, you have to move the bound, right? So put a negative in front and move the -4 down and the -3 up. And now we've got to find the area from -3 to -4. Okay. Or -4 to -3. So this is going to be just this piece right here, just this triangle. What's the area of this triangle? Y'all know it. Come on. 1, right? So my final answer here then would be -1. So far, which one is winning and to be my absolute min? The -1. Okay, so I know that my -5 is not going to be the answer. Okay, on this next one, if you can, before you get to the end, figure out that this number is bigger than -1, you can stop there. Okay, but if you think it's close or think it might be less, we've got to figure it out. So, g of 4. Okay, do I need to switch the numbers on this one? No, not at all. Okay, so if we go back up the top, I'm going to use yellow on this one. This means that I'm going to start here. I'm going to do all this. Okay, I already found that to be 9/2. So I already got part of that done. Then I've got a little bit more to add. Looks like some circle stuff. I'm going to have to subtract from the circle. That could be annoying. But then I've got this triangle and then this triangle, which I'm going to subtract, and they're the same. So yeah, this whole part doesn't matter. They're going to cancel just like how in the beginning. So I have 9/2 plus something. 9/2 plus something, which means that the integral itself is going to be positive. Could that be my absolute min? No. And I'm glad, because I don't want to have to figure out what the area of that little piece is by the symmetry. So that's not my answer either. And so what we would want to do here is write out our answer, like G as an absolute min of -1. Because remember, this is the min. And you could say at x equals -4. And we've seen that before. -1 is the min. The location, you could say when or where, at, any of those would be fine. Okay, so now we have the last thing. We have G points of inflection. All right, what's the deal with points of inflection? Y'all hang with me here. We're going to do this, and then this is it for the notes. I'm going to help you on some of your homework. What is a point of inflection? When the concavity changes. Okay, so G should change concavity. Well, I don't have a graph of G, so I can't tell that. So what else may be something about G double prime?
G prime 0.
So G double prime is going to be 0 at a point of inflection, but what if it's negative on both sides and then is only 0? Is that a point of inflection? Right, it has to change signs. Okay, G prime equaling, or G double prime equaling 0 is a possible point of inflection, and it is most of the time, but we have to say G double prime is changing signs. Well, what was the same as G double prime? F prime, the slope, right? And this again is why we wrote all this, okay? The slope. So we're looking for, where is the slope changing signs? Where are we going from a positive to a negative slope, or negative to positive slope? Basically, where is the graph going from increasing to decreasing, or vice versa?
At x equals -3.
Yeah, here.
X equals 0.
Is it happening at x equals 0? The slope
no.
is continuing to be negative. What about right here at 1?
No.
Yeah.
Yes.
Yes, this is a very strange thing, but the graph is decreasing and then increasing, meaning that G double prime is changing signs. And then also right here too. So -3, 1, and 2. That's where that's happening. It doesn't say we have to justify, so you don't, although what I've written here would be a good justification. Okay, we're going to stop here.